Alright guys, so today we'll be talking about similarity and right triangles, and we're going to talk about a really cool thing, and I'll show you a little trick on the next slide for geometric mean. But if you're dealing with a triangle, a right triangle, and you draw an altitude from the hypotenuse from the right angle to the hypotenuse, okay, you can actually make three triangles that are all going to be similar. Okay, so all three are going to be similar. Okay, so when you're setting this up and just working across this, you could actually set up these extended proportions. Alright, so here's the three sets of extended proportions you can actually set up from this one triangle. Now what my recommendation is to rewrite the triangles in this order. Okay, so if you don't choose to do this, you're going to be sorely confused as to how I got these proportions. So when you see this, rewrite the triangles and put the right angles at the top. Like, see, the right angle is C and then two D's. Okay. Alright, now this first one here is these two being compared. Okay, those two being proportional. Alright, the second one, AC, yep, it's this one. It's these two being compared. And then the third one, right down here, is going to be these two compared. Okay, so you can actually set it up and just work with it however you want. And the cool thing is that you can just use this relation to figure out these relationships. Now, you could use this to help you get the measurements and just work that way. I think a really good way to actually do it is to use the geometric mean, which I'll show you next. Okay, so the geometric mean is really cool. Alright, so here's how I remember how to do it. So what I do is I just need the bottom part, and this is the hypotenuse broken apart into two parts, and then I add those up and I should get 36. Okay, here's how it actually works. Alright, now if you're missing x, okay, here's the really cool part. Oh, come on, I wanted green. There we go. Okay, is you're going to use these three right here, and x is going to be equal to the square root. Let me get off the caps lock. That would be nice. Right, and square root is 251 of 12 times 24, and that's it. That's the beautiful thing of it, and you can actually find x that way. Now if you wanted to find y, you would need these three numbers. Okay, and this is the really cool thing behind this. Y is alt 251 of 12 times the entire length. Voila. Alright, and here's the cool thing. You can probably see where this relationship is going to go. Z is going to be these three parts right here. Okay, and Z is going to be the square root of 24 times 36. Okay, and you can actually work those out. Now let me see. Square root of, well, I need the parentheses in there. Whenever you're doing it, make sure you have in parentheses or it's underneath it on there. Okay, and you're going to get your approximations and everything. Okay, you'll probably write it as your roots. So let me see. What is 12 times 24? 288. So this is going to be 12 root 2. There we go. Okay, and we'll do 12 times 36. Now how did I do that so fast? 12 times 28, or 12 times 24 is 288, and 288 is equal to 144 times 2. So that's how I broke that apart so fast. Okay, now this is going to be 432, which is, okay, this is going to be 216 times 2, which is equal to 6 times 6 times 6 times 2. Okay, now if you think about that, that's, you're going to have those two sixes, so that's 36 times 12. Alright, and then if I break apart that even more, that's going to be 36 times 4 times 3. Okay, so that's going to become 6 times 2, so that's 12 root 3. Okay, so that's the gorgeous thing behind it. And then this next one is going to be 24 times 36. This next one is going to be 12 root 6. Okay, because it turns into, what is that, 864? And 864 is 144 times 6. Okay, and technically this should actually turn into 144 times 3. Okay, so that's how I got those. And that's how you're able to break them down and stuff. If you get the decimals, I'll be totally, I will understand if you get decimals, but this is how you actually work it out. And this is the geometric mean, ladies and gentlemen. And normally they just go over this one right here, the how to find x, or the height of the altitude, but you can actually find the y and z as well. Okay, just by knowing these two measurements of the hypotenuse. All right, that's it for geometric mean and similarities and right triangles. I'll talk to you guys later. Bye.